couple of other things about soil and how soil interacts with water. Soil and storage capacity, or how well the soil can store water. Clays can actually store more water than sand can. To me, it's a little counterintuitive, but clays are tiny and they have an irregular surface, and they end up having more surface area, thus can store more water. Sand, on the other hand, this is a microscopic view of clay and a microscopic view of grains of sand. Sand, however, allows the water to flow through it much easier. It's called percolation. That's how water gets down to the ground, into the ground, and becomes groundwater. So water can move in two ways. Primarily, it moves by gravity, which is easier in sand because sand allows the water to flow through easier down to the aquifer, down into the to the zone of saturation in our aquifer. There's also something called capillary action, where water can flow in the other direction. And it's kind of like getting whipped up in a paper towel. So here you put a paper towel on the spill and it's wicking up liquid. So the liquid is actually moving against gravity in the narrow spaces of the paper towels. And because clays are smaller, that this capillary action is actually easier in clays than it is in sand. Soil also has pH, or can be more acidic or more basic. So alkaline soils are more basic. They have a high pH. This would be like, so neutral would be 7 on a pH scale. The lower numbers are more acidic, higher numbers are more basic. Alkaline soils are those that are more basic. Actually move this down a little bit. And acidic soils are more acidic, and the best soils are neutral, around 7. If they're too acidic, they leach out nutrients, and if they're too alkaline, they don't allow the nutrients to dissolve. So water that, or soil that has a neutral pH is better for productivity. So for example, in the United States, in the wetter parts of the United States, you have more acidic soils, and in the drier West, you tend to have more alkaline soils. So it tends to correlate with the type of climate you have as well. Also, plants tend to add some acidity to the soil. You have more plants where it's wet. There's also soil forming processes. We'll just take a look at a few of these that go along with climate. So in tropical wet climates, you have a process called lateralization. In drier climates, you have other things like salinization and calcification. Let me just give some example. Lateralization is something that happens in tropical environments where there's a lot of rainfall and a lot of nutrients get washed out and leave behind things like iron. And that makes the soil can be this red, rusty color. In California, we tend to have more of a dry environment. And in Mediterranean, where climates that are a dry summer, you can develop calcification. One thing calcification do is lead to what's called hardpan. Hardpan is where you have a hard layer of soil underneath. This is showing a cross-section of an almond tree and its roots trying to grow. They can't penetrate a hardpan soil underneath. In some parts of the valley, we also have problems with salinization. Salinization is where there is a shallow water table and salts can accumulate up at the surface, and that can be bad for plants as well. You find this especially on the west side of the valley in kind of along, we've talked about Lake Corcoran in the past, that general area where you had Lake Corcoran, you still have a kind of a shallow water table, there is still a clay layer underneath, and that can lead to water quality problems like having too much salinity.